Younes is based in Lyon, France, and I love it because he's a software cook, and so he does a lot of things with recipes and cooking up your applications, and it's just so clever and fun. But he's a teacher, coach, and a mentor, really. And do you own? It's called Marmacode. So is that your owned? Okay.
Yeah.
So he owns it. In fact, check it out. It's seriously a fantastic website, marmacode.io, and you can find a lot of his fake it till you mock it stuff on there. Just really well put together content. So love that. But then in addition to that, he is, as we've been saying, a speaker around the world, and he's an Angular GDE and an NX champion. So knows his stuff. We're very lucky to have him. And yeah, I'd say, Eunice, it's all yours. We'll let you know when there are questions.
Cool. Thanks. Well, that was a perfect presentation. You should travel with me to present.
Okay, there we go. Fit me in
Thank you
your
so much.
suitcase.
Let's do that. Um, wait. Oh, sorry, there's just someone. One sec.
Sure.
What is happening here? This is supposed to be an audition. Where are these people here? Younes, what did you do again? What a mess. All the time. Okay. So, I don't know who you are, guys, and sorry for this, but we have a little audition, then I'll just pass the mic to Younes. And, well, sorry that there's a conflict or something, I don't know. So, bring the first candidate, please. What's your name?
Dummy.
Okay, nice to meet you, Dummy. Let me give you some context. So we're building a recipes application, okay? And like any other application, it's just a couple of pieces of code, chunkies like you that live together in this village in order to make this app work. Of course, each chunky is different. Some are a bit crazy, some are young and think they're modern and cool, some are older and they think they know it all, and some are clean and others have questionable hygiene. You know, it's code, chunkies. So anyway, you'll learn to love them. And so here's the general architecture. So we have an application, typical architecture with or structure with container components like recipe search, which is the components that orchestrates everything. And we have two presentational components that handle the recipe preview and the filtering, you know, the form. And so that people can search for recipes. And we call a recipe repository, which is a service that fetches recipes from the network today, but we're not settled now. Maybe we'll use HTTP, maybe some GraphQL, maybe we'll just ask some local storage if there is one. We don't know exactly how we're going to handle that now. But anyway, we have an abstraction, it's this recipe repository. And when people or users click on the add button, the recipes are stored in a meal planner so that you can plan your meals for next week. And the thing is that we have a really great chunky for the recipe repository role, but they're really busy. And, you know, they're very expensive. Each time we call them, they're like, yeah, it takes hundreds of milliseconds for them to respond. And sometimes they respond with other data from other testing scenes. So it's really hard to work in this condition. That's how we get to you. We have some scenarios and stunts we'd like to test on the recipe search component, and we are looking for a test double, okay, for the recipe repository. We want someone or some chunky to replace it for the extreme tests that we'll go through. And this is the job we're auditioning you for.
Dummy!
I love the enthusiasm. Great. So for the first scenario, we just want to make sure that when we load the component calls you and you just respond with recipes that will be displayed.
Dummy.
Good. So I'm going to render the component. Ready? Go. Computer, zoom on the script, please. What kind of dummy is? What kind of test double is this? It's just a string. it's not, I'm not gonna replace, we're not looking for extra smiling in the background, we're looking for actors. This is confusing. Well, thank you, dummy. We'll get in touch with you.
Dummy.
Bye. Okay, so this one is gone. Next one, please. What's your name?
Stub.
Nice meeting you, Stub. As this is not a private edition anymore, there are like a few dozen people here, you've heard the intro, okay? So whenever you're ready, let's do it. Let's go. Your turn. Oh, sorry, I think we have a problem on our end on the components. Don't move. Computer, go to code. What? Don't understand what's wrong. Wait a second. Debug the value of the search recipes results, please. Oh, okay, so the stub responded with undefined. Okay, so listen, Stub, you should answer with an observable emitting an array with two recipes, burger and salad. Okay, that's our scenario, okay? Like this. Okay, so next time you respond with this.
Oh, okay.
Okay, good. Well, let's go. Ready? Good. Now, what happens when I start typing BUR, like searching for a burger in the form? Dummy. Sorry, Stub, is that your name? You're supposed to answer burger this time, not burger and salad, because I'm typing burger, you know.
Oh, okay. Just give me the lines in the exact order.
Okay, so the exact order is the first time you're going to respond with burger and salad, and the second time you respond just with the burger, okay? So, okay, anyway, so let's move to another scene. We don't have much time. There are people waiting for the room. So this time in this scenario, I'm rendering a component, but the keywords are not typed by the users. They are coming from the router, you know, from the URL, from the query parameters. Okay, so when the component is rendered, it's grabbing the keywords, it's going to pass them to you, but it doesn't matter for you, right? Anyway, so I'm going to render the component, and your turn. What? You're supposed to respond with just the burgers, you know.
Isn't this the first answer you were expecting?
No, but it was the answer I wanted for the other scene, but now I want you to respond with the burger. I can't give you all the answers in the exact order for each scene. Do I look like someone who scripts everything? I'm not a playwright. We're just improvising things here, so we have to find a solution. We can't give you a specific script for each test. You'll have to adapt, you know, that's real life. So what happens, by the way, if we call you with wrong arguments?
Oh, I don't know. I don't check the parameters. It's definitely not my job.
Whose job is it? Anyway, so thank you. We'll get in touch with you. God. Who did the pre-screening? Is that you? Yeah, I can't work in these conditions. And this is all we have? Okay, so this is not like, oh, there's still some people. Okay, bring the next one, please. What's your name?
Hello. You can call me Spy.
Okay, nice meeting you, Spy. Let's go. So I'm gonna type the keywords directly, okay? Ready? Here we go. I'm typing the keywords. Now, render. What? Are you there? Should I repeat, or can someone bring something to drink? Okay, do you need anything else? Are you right?
No, I'm fine. I'm just keeping note of everything the component says to me so that we can check later if the component is not making any mistakes.
Okay, I got it. But that's nice of you. Indeed, that could be useful. But without an answer, if you don't respond, the component might be disappointed. It's just waiting there, you know. And by the way, I couldn't but notice that you're wearing matching Jazz shoes. What if we move to another studio where we want you to remove your Jazz shoes and put on a V-test hat? Would that work for you?
Oh no! I'm highly coupled to my Jazz shoes. I can't switch like that.
Okay, that's annoying. Anyway, we'll figure that out. Thank you so much. Oh, the Stub and Spy could work well together, but they're high maintenance. They require lots of configuration. We can't afford that right now. Anyway, next. So, what's your name?
Monk.
Okay. Okay, so let's go. We'll...
Wait. I have to tell you a bit more about the way I work.
Okay.
First, you'll have to tell me everything about all the calls that I will receive. I won't let anyone call me differently from the script. And if that happens, I throw errors at them.
Okay. And what if they just catch them?
Why would they do that? They shouldn't.
Because they can. Anyway, what if they don't talk at you at all?
Oh, you'll have to tell me when the scene is finished, and I'll verify if they called me properly, then let you know.
Okay. Now, what if we change the script a bit?
Then of course you'll have to tell me about these changes for each scene.
Yeah, but okay. Thank you. We'll never make it. Who brought this one? Sorry. One candidate, last one, okay? Then we're over. I'm exhausted. What's your name?
I'm fake.
Okay, and are you ready? Do you need the order of the answers, or the expected parameters, or the testing framework we'll be using, or the temperature in the room? What's your trick?
No, I'm fine. I've read the character description and I feel that I can really grasp its identity and imitate it. I just need the list of all the recipes we'll be playing with and I'll figure out from there. So just shoot and let's see what happens.
Okay, let's go. So, sounds good. So here are the recipes that I want to display. Okay, I'm gonna render the component. Your turn. Cool. Now, what if I type BUR? Okay, ready? Cool. Okay, let's try something. Let's go off script. I'm gonna type whatever, like Baba Ganoush. Okay, can you find something? Wow, the error message. Perfect. This is great. One last thing, how can we make sure that we don't get bad surprises in our tests and, well, the test pass and then we switch to the real implementation and then we get bad surprises in production? How can you assure us that it's going to work for us?
There are different ways. One of them is this contract test that both the real implementation and I sign. If the contract changes and one of us doesn't comply, you'll see it immediately.
Cool. I love that. Now, what if we move to another studio where we're working with other tools like, I don't know, VTest or Playwright? Would you be fine with that?
Of course! I'm testing framework agnostic, so I can work in any studio.
I love that. Anyway, thank you so much. You'll hear from us, that's for sure. Cool. Okay. So thank you for watching. Now we can start the more interactive part. So who am I? Well, Brooke already told everything. So I'm Younes. You can find me on these socials. Software cook, and I'm also a software coach. So I try to help teams build better apps. So I can coach and make workshops, and I have like a testing video course. And I'm out of time. So let's move on. Oh, by the way, how much time do we have? Because I can speak a lot.
You have about 40 minutes left.
Okay, good. Oh, plenty of time. So why am I here? Well, I'm here to talk about mocks, okay? So mocks are a big topic and we're always like, yeah, how do we handle the mocks and everything? But the first thing that I want to talk about is that mocks are not what we think they are. And there is like this very old article from Martin Fowler about mocks not being stubs, as they would say. Mocks aren't stubs. So there are different test doubles. So that's the family of test double. That's the family of, the things that will replace services or components or whatever thing in our software for testing mainly. And there are dummies, mocks, fakes, spies, and stub. And the funny thing is that we keep calling them mocks, but mocks are a very specific thing that is super rare in real life. But anyway, so why do I want to focus on this? Why do I make this distinction? Is it just because of the wording and just to be strict about it? No, no. It's very important because the way we mock in general is problematic and can make testing more expensive and painful. And the thing that we use most actually, and we call mocks, you know, the mock return. Oh, and so the spine stubs. So what we call mocks in most of the time is actually spine stubs. You know, the mock return value, that's the stub part, you program the return values. And the spine part is when you spy on the parameters or the arguments that you received. How many times my function was called, how was it called, and everything. Okay? And the mocks that I'm not going to cover here are a very special thing that I got into a bit more detail in my article in my cookbook, and I'll share the link later. And the mocks are super rare. It's something that you pre-program with return values and calls. You're like, okay, this is a mock. It's going to receive these calls, this calls, this calls, and it will return this. If it receives this call, everything is pre-programmed, and you prepare it and use it in your tests. And we don't do that much. And it's problematic too. And the other option, which is, in my opinion, the most versatile and that works best, is the fake. And we don't use it enough, in my opinion. And that's why I've been talking about this thing, about fakes, for a while now. And so what we're going to do is we'll try them live together, and we'll see what works best. Okay? Okay with that? I'm just gonna grab my apron so that we can cook. Let's heat this up. I'm gonna prepare my IDE here. Oops. Okay. Good. So I have the recipe search component that is already here, okay? And it's actually calling the can you see my code?
Yes.
Okay, cool. Don't hesitate to interrupt me if, I don't know, if my screen is not sharing anything or if the sound goes problematic. So we're just using Rx resource to call our repository here, the search method that we've seen before, pass in the keywords and grab the result and display in the list in the view here, showing errors and everything. So, well, ideally this should have been TDD'd and we should have started with the test, but so I'm going to render, but it helps to understand the code first for this example. So I'm rendering the component. I'm using Angular testing library, but that's just a technical detail here. It's not relevant for the fake versus mock problem here, or fake versus spine stop here. So I'm just rendering the component, and I'm returning some utility functions that will help me interact with the DOM directly from our test, because I'm going to reuse these queries a lot. These are not Angular testing harnesses, but I like to call this pattern in general, I like to call it gloves to be more specific than harnesses. So gloves is anything that prevents your tests from getting its hands dirty with implementation details. So what I want to do, and I'm using vtest here, okay? What I'm going to do is I'm going to render the component here, and I'm going to check that it has two recipes there, but I want to check that burger and salad are displayed. But the problem is that where do these burgers and salads come from? I have to pre-program my my test here and provide a test double with the burger and salad. But anyway, so let's assume that it's already there and just write our test naively here. And I'm going to just use the find recipe titles and expect that elements to have a length of 2. I'm expecting 2 elements, and the first one to have text content burger, and the second one is salad. Obviously this is not gonna work, but let's see how it goes. I'm using Wallaby.js, which is an amazing plugin for VS Code and WebStorm for testing. It's not free, sadly, but it's super powerful. And my test is failing here. And to make it even more classical, I'm going to open a terminal here. And I'm going to run my test too. So, okay. So the test is failing because the repository is using HTTP client under the hood, and that's not working for us because we don't have the HTTP client. And the thing is, I don't want to provide or to double the HTTP requests because I don't control the HTTP API. That could evolve a lot, and I don't want to update my tests each time the API changes. And also, I don't want to update all my tests. That's what I mean. And also, if I start doubling the HTTP communication, that's an infrastructure and implementation detail problem. And the HTTP response might contain, I don't know, 30 or 100 properties that I don't care about. And in my app, I only use 2 or 3 of these properties. So why would I start doubling responses and handling stubs and fixtures and pre-stored responses that contain hundreds of properties? And it would be even more dangerous if I start making invalid HTTP responses that are not the same as the backend and that have only the subset of properties that I use today. And if they change tomorrow, then my test will and if tomorrow I start using other properties, my test will break just because I didn't have like the full response. So anyway, so providing test doubles at the HTTP level, whether you're using Playwright to intercept the request, whether you're using MSW, whether you're using HTTP controller, HTTP testing controller, that can cause problems. It's gonna highly couple your test to the communication, to the HTTP communication. It's gonna make the test harder to maintain and everything. So it's trouble in the long term. Anyway, so I have this code here, and so instead of replacing the HTTP client with the testing client, I'm going to replace at my abstraction layer. So I'm in my core, I'm in my world. It's something that I control. It's for people who like hexagonal architecture. That's I'm going to replace my port with an abstraction, with a fake, or sorry, with a test double. And now here we're using a spine stub. So here I'm going to provide. I don't see the chat, but if there's any messages, let me know. And instead of the recipe repository, I'm going to provide a repository spine stub. So how do I create this? Here, you're familiar with this probably. Or maybe jasmine.createSpy or jest.fn. You've seen this. And here I'm in vtest, so it's v.fn. And I want it to be type safe, so you can make it type safe. Here in vtest, it's you have a type called mocked. You have a generic for this, and it's implementing recipe repository def, which is this is an interface that defines the recipe repository. You don't have to create an interface. You could also use the implementation, just use the public APIs of the implementation, but that's a tiny detail. And then I program my spine stub here, and I program it with to return always a list of burger and salad. Here, I choose to do this here and not here so that it's type safe. Because look, if I do this here and I return 42, it works because this spine stub method here is not typed yet, but the return, the whole object is typed. So when I call this here, I cannot put anything, I cannot put something invalid, except if I force it, of course, you know. You don't want to do that. And here, imagine I return just, I don't know, a burger and a salad. Still don't know what is a burger and what is a salad. This is not valid because I'm returning an array and we're expecting an observable. So I'm going to create an observable. And imagine here, I'm implementing the component and I have to handle this and create observables. There are a lot of things I have to think of now. It's already annoying because maybe the repository will switch to something else. Maybe it's going to return promises. Maybe it's going to return a signal. I don't know in the future. And I would have to change this each time I refactor. And now let's create the burger. So here, instead of just creating the object manually like this, and this one is just a recipe and it's already complex. Now I can only imagine the complex objects that you have to handle in real life. And I could have like a factory function or something, but that's not enough. And what is better is a really old pattern called object mothers. And I have a recipe mother that allows me to create recipes like this. Okay? Then I could create something like this. And it uses the builder pattern or chaining to add other stuff. And what is interesting here is that this makes the intention very, very explicit because, okay, you're creating just two recipes with different names, that's it. If tomorrow I add other methods like with vegan ingredients and then I add like a vegan user and I try to test them with some method, then I can understand why the vegan field is true or false. It's not like when you have like a big object and lots of properties are filled there and you don't know why the developer put this value here and that value there. So I just have this. And how do you implement this? I've chosen to use a class here, but you could do it with objects and in plain objects without creating a class or everything. And now I can use them. Great, finally. So here I've prepared my mock and I prepared my spine stub, and here it's just the stub part, and then we'll check how it was called. It would have been a mock if we would do something like this, like mock implementation once, and make sure that the arguments you receive here are this and this and this, and in that case return this, otherwise just fail. And this is very cumbersome, and we don't use it that much. And that would be the mock. And this is just what I call a spine stub because it's a stub and also a spy, even though we didn't use the spy part yet. Great. Now, cool. My tests are passing here. You can see that. Okay. I'm happy with this. Perfect. And now let's, the thing is that when you use stubs or spine stubs, nothing tells you if the repo search was called properly or not. You have to check the received arguments to make sure that there's nothing wrong there. Because maybe my component here is doing something weird, like always passing invalid keywords, okay? And let's see if our test is passing. This test is still passing, but it shouldn't because we didn't check this. So let's return the repo here, and got it. And after I've checked this, I'm going to check that to have been exactly called once with undefined, okay? Didn't receive any keywords. There's also an interesting thing here with vtest. is that it's just a little tip. If imagine this is invalid, like type in burger, yeah, let's like this. So this test is failing, but I can't know if this is failing or not. And sometimes you have multiple assertions, and it's hard to you fix this, and once you fix this, you discover that this is wrong here, and the problem is actually there's another root cause for the problem, and you didn't fix the right one. So there's an interesting thing with vtest is that you can make soft assertions, just like in Playwright, by the way. And now it's checking everything, so I can have both errors simultaneously. It's actually making all the assertions and then reporting all the errors. Okay, good. Now we're good with this test. Now let's try the second one. And website. So here, okay, we're preparing everything, and this time there should be only one recipe, and it's displaying burger and only, and it has been called with burger or BUR, because I was just typing BUR, okay? And the thing is, of course, the test is failing. Let's see. The test failed because what do we have here? Okay, it wasn't called properly. And what are the other errors? Oops. Let's see this. To help length. Okay, yeah, there are still two items there. Sorry, there are still two items, and because of course our stub is just programmed to always return the same thing, so we have to reprogram it here. Okay, and be like, okay, this time I want you to just return after the component is mounted and everything. Just before I'm typing, I want you to return the burger. An observable with a burger in it. Oh, where does the burger come from? Oh no, I have to grab it again here, so I'm going to return it. So I'm using this setup function for that. Okay, and how's the test going? Oh, there's still a problem here. Well, this time the problem comes from the fact that there is a debounce in the recipe filter and it's waiting 50 milliseconds. I'm not going to use fake timers in advanced time because it's just 50 milliseconds. So what I'm going to do is, there are different ways of doing this with vtest. Is you could use vtest wait for, and you just ask vtest to wait for this to pass. You just like, please try this forever until it passes or it times out. And how's it going? And wait a second. Oh, okay. To have been called exactly once with BUR? But it's not working. It's saying the spy was supposed to be called once with just BUR, but actually it was called with undefined. Like, how come? This is hard to debug. Let's try search. Now I have to be an expert of how jest or vtest spine stubs work. Where is it? Oh, it's in mock. That calls. Okay, I can see the list here. What's the list? Okay, it was called only once with undefined. Oh, of course. Here it's saying it should be called once, but actually it was already called once with undefined when the component was loaded. Now I typed burger, so it's the second call to the repository. So what I could do, instead of making the same assertion as the first test again, I'm going to do something like mock clear, and it's going to clear the counter. And now let's see how it goes. And this time, so it wasn't called again. What happened? Type keywords. What happened here? Oh yeah, the soft assertions don't work with wait for. Sorry for that, because of course you're waiting for errors, and it's retrying only if there are errors. But if everything's working, it's not working. So let's try again. So if I don't do this, okay, I'm getting two recipes while I should be having only one. Now I'm reprogramming this, and this time, this is the failing part. Everything's working, but the repo was not called properly because it was called twice. Once with undefined, and then a second time with bur. And you can see that this is hard to read. Like first spy call, second spy call. Oh no, I cannot see them. So no matter the tool you're using, it's going to be cumbersome. And now let's see how it goes. Gonna mark clear. Okay, now the test is passing. Wow, phew, that was exhausting. Look at this test. It's horrifying, isn't it? Now let's see how robust this is. Let's say I'm gonna grab the recipe filter component and remove the debounds. Okay. Oh no, my tests are failing. Let's see. The tests are failing. Yes, because the repository is receiving B, U, and R. You know, each time I type a character, it's receiving the string. And I don't care about this because recipe filter debounds is already tested somewhere else. Here I'm in the parent component, so I don't have to care about that. So now I have to go back to the test and change my assertions and not check that it's called once, but just say, okay, it's the last call, and that's it. So to have been last called with, yes. Okay, the test is passing. Great. Anyway, so it's a bit fragile. Now let's do another refactoring. So to have been last called with undefined. And, oh, sorry, here we don't have this because there's only one column. Okay, great. So all my tests are passing. Let's see. Good. Now let's try something else. I'm going on in the component, in the repository, this repository here, and I've decided something that happens all the time. There are too many parameters here. I'm going to convert this into an object. Great. My type here is broken, so I'm going to fix it. Okay. So I've changed the implementation. I'm not sure the ID picked up. Oh, here it's not okay. You have to pass parameters. Great, I refactored, I changed the service, I changed the implementation, and I'm super happy with this. Oh no, sorry. Let's keep this here. Let's say this is not typed properly for some reason, or I didn't type check. And look at this. My tests are passing. Why? Because the test is valid in terms of typing, even though I made lots of effort into this for the return value. The parameters here in the assertions are not type checked. So my component is calling the repository the wrong way, and the tests are passing. Great. So this is what we call false negative, because the test is like, there's no problem, just go to production. But there is a problem. So, let's fix this now. So I finished the refactor and I found the bug, and now my code is working. And let's see how it is going with my tests. The tests are failing because I have to change all the assertions. Now imagine how many tests are using the repository. Maybe there are like dozens or hundreds. So you'd have to go through all of them and start replacing this. Okay, this is undefined. And this is bur. And you can use an AI agent, but then would you trust like hundreds of tests being changed? You'd have to review that. So it's very, very, very problematic. So this is expensive. So that's the problem with spying stubs. Now let's try something else. Okay. Now, I'm at the same starting point. I have my tests passing with the spine stub. But the new thing is that I have a fake implementation of a service. This is nothing new. It's pure TypeScript. It's a class implementing the interface. And here it has a search method that does some asynchronous logic here. So it's a defer so that it only triggers this when we subscribe. And it's filtering the results with the keywords. If the keywords contain error, it throws an error. So it's a bit complex, but I could have used something simpler. But anyway, that's just to show you how the fake can be smart or not. And here I'm filtering the recipes. And the only method which is different from the real implementation is that there is a configure method that allows me to configure this fake with some recipes. So let's try it out. In my test here, instead of doing all this, I'm going to provide the fake instead of the real implementation. And to do so, instead of just configuring this here, I've created a little provide function that replaces the repository with the fake, but also provides the fake so that I can inject it directly with the right type. So how's that work? So I just have to replace this with provide recipe repository fake. And before I render the component, I'm going to inject the recipe repository fake and configure it with recipes that are burger and salad. How cool is this? And I don't need repo anymore. I don't need to return the burger. Now I know that in this group of tests, I'm always having a burger and a salad in the list. And now I'm just testing the behavior, not the interactions. I'm like, okay, when I render the component, it's showing a burger and a salad. And when I'm typing keywords like BUR, I don't have to orchestrate anything. I don't have to check the calls. And my test is passing with less code and it's more explicit. Now, let's see. Imagine that I commit this. Okay, my test is passing. Now, let's do the same refactoring as before. I remove the debounds. My tests are passing. Let's make sure. Great. Now, let's go back to the repository and refactor it. Yeah, here. And I have to do the same thing here. Okay. And now the fake is broken. I could see it because I'm the maintainer of the repository. So I maintain the fake too. It's not up to the testers that use my fake. It's me as the person implementing the repository, and I know how it works and everything. In case I forgot, I've got, of course, type checking. Type checking would have told me, okay, there's something wrong. The fake is not, it doesn't have the right type. So I'm gonna change this here too. I don't know, I know there's an issue with the ID. It should have been refactored, but anyway, I have to do it manually. Great, I refactored everything. The real implementation and the fake. Now let's look at the tests. The test failed, and I'm like, why? What happened? Oh, it displayed something wrong. Something wrong is displayed. So I could start debugging and everything, and then I realized that actually there's still, I didn't refactor the component. So here we have a true positive. The test really found a bug. Good. So I have to refactor this, and my test is passing. Great. Oh no, sorry for that. It's more like this. Yeah, we're happy. So the tests are passing, and the amazing thing is that, look at this. I did not touch any test. So if I had like hundreds of tests, everything would have worked. Now let's go beyond this. What if I'm just going to go to the solution. Now, how far can that go? I can use Playwright component testing. And here, I'm in Playwright. I'm mounting my components and everything. And in the configuration, I am using the same pattern. It's the same fake, configuring it with the object mothers and everything. There's nothing specific to any tool. And if I run this with Cursor or VS Code, because they have a super nice integration with Playwright, my tests are passing here, and I could choose to only run Chromium, and let's debug one of the tests, maybe just this one. And, oh, it's here. And now look, I'm using my fake, and I can start debugging here, the selectors, and I'm like, oh, this is not the right one. I'm checking and here I could check all the elements in one assertion, which is super nice. And how's this going? And now this is not working because it's burger and salad. And let's try again. And if I go back to my configuration, and I don't know, let's add a beer. Okay, how's it? And, oh, sorry, it's not. Watch mode is not enabled. And oh yeah, the beer is on the right. Okay, so this is just to show you that we can reuse the fakes everywhere, and I could even start my app. And in my app, I could have like a flag that enables these two lines. I'm just loading the fake and then using the app initializers to initialize my fake. Then I could use it here. Sorry. Give me a browser, please. Okay, and here I have like a real app, and I'm using my fake, so if I start typing some like burger error, something went wrong. If I say burger delay, because my fake is a bit more smarter and responds with different, it changes its behavior depending on the keywords. Okay, so that was all about the coding. Now let's get back to the slides. I always forget the apron, so I need to keep the notes there. Great. So, let's summarize this. So, who wins? You tell me. So, in my opinion, it's the fake. All the time, or really all the time. There could be some extreme scenarios, mainly with legacy code, and you cannot build up a fake for something that you don't even understand how it works completely. I don't know. So in some extreme cases, the spy and stub could be useful. But then we're coupled to the testing framework and everything. And you have all the maintenance problems and false positives, false negative problems. And the thing with the fakes is that you focus on the behavior, just like the users, just like human beings. It's cheaper to maintain. It's refactor friendly, and it's symmetric to production. It behaves exactly like production. I didn't show you here, but I also have a contract test on the repo. You see it. It's the same test that runs on the real repository against the real backend and on the fake to make sure that they both work. And it's reusable. It's framework agnostic, so you can change your testing framework and everything. It's easy to debug. I didn't do it here, but you could add console logs in the fake. Why not? And less cognitive load. You don't have to worry about many things. There are just few gotchas, and that's the last thing I want to share with you about this, is you have to keep them simple. In my case, I made them a little bit this one is a bit too complex. I just wanted to show you the limit. But you can make them, you have to make them configurable. Don't put the hard-coded data in them because that would make the test harder to read. Where does the burger come from? And documents the behavior. You've noticed this maybe in my code. I'm saying, okay, if you call me with delay, I'm going to add 1 second delay. And only fake what you control. Don't double things you don't control, like an API, like the router navigate. No, that's not your job. You don't know how the router really works. What if I call another method that navigates? And what if that changes? And also, do not fake the world. Okay, fake only few services that you really need to fake, like infrastructure and everything. Try to make bigger tests, and because tests and code are like sociable creatures and they work well together. So last thing, fake it till you mock it. So please try use fakes and let me know how it goes. It's like I created this because I've been coaching teams where I was hesitant at the beginning because I used that and I didn't know if it would work for everyone, and it worked for everyone. So please try it, and if it doesn't work, then you can fall back to mocks or spy and stubs. Thank you. Just one last thing. You'll find the slides in the code here on this link, and you will find the link to my Angular testing course where there's this kind of tips and 100 more. So please check it out. And I have a special offer for you. You will find many things there. And I have a special offer that didn't display. Wait. Oh, that's not enough. Oh, that's too much. Well, too late, it's there. So you can use this special code or just scan the QR code. And this special code only works for 24 hours and there are 5 seats. So don't fight, but it's like, it's a real super opportunity just to thank you for being here at, I don't know what time it is for you, maybe noon or evening, and you have better things to do. And thank you for listening. And I hope I didn't eat too much of your time. And I hope this improves your Angular experience in general.
Does anyone have anything before we let Younes go?
Yes, we have one question. Is it can you use faking with React or other frameworks?
Yes, of course, totally. And like among the teams that I've told you about, there were lots of React teams too. So, and you can use the same pattern for backend, and you can use it beyond the JavaScript. So that's also what's interesting here. It's not like, hey, here's another tool. It's more like, here's a pattern for life. So, yeah. The only challenge with React is that you will have to figure out a way to override the dependencies in your tests. So either through some dependency injection, you could use the context, but the problem with the context is that it only works in the JSX tree. So some teams use things like Syringe, which is a dependency injection that works almost like Angular. It's a similar API, but it's way different though. But anyway, so yeah, you could use it as long as you find a way to replace something with something else that is test and framework agnostic. Even a singleton is good. Well, I said it. Singleton.